Hello, everyone. Welcome to today's ACT office hours. Today we have some Magoosh Premium students joining us, as well as some students from our YouTube channel. So welcome to all of you. It's nice to have you here with us. Glad you joined us, whether you're here for the first time or not. Let's talk a little bit about what we're here for. This is our office hours. This is just like if your teacher was still in their classroom at the end of the school day, you have the opportunity to stop by, ask a clarifying question about one of the assignments, something you learned in class, what is going to be on the test next week, and have a little bit of one-on-one time to just get your personal questions answered. And that's exactly what this is going to be like for us. So I am your expert instructor today, and I'm here to help you with any questions that you have about the ACT or about specific ACT questions. So what we're going to ask, if you are joining us from our normal Magoosh Premium Student Office Hours link, go ahead and use the question and answer function in your Zoom. If you're joining us on YouTube, you can throw questions in the chat, and our friend Ken is there to monitor the chat and send some questions along to me. If we're not able to get to every question in time, I'm so sorry about that, but we will do our best to answer as many as possible. That being said, let's get started. I have a practice question that has been submitted, and it is this Magoosh question. We have here a reading passage, and we have a question about what's going on in line 84. So let's see. The question says the word lethargic most nearly means. So this is a vocabulary and context question. On questions like this, we want to be careful not to just rely on the answer choices. We might see the word, we might say, oh, I know what that word means. The answer is right there, and just choose that. However, these questions are really about what the word means as it's used in the reading passage specifically. So a lot of times, all of the answer choices can be different meanings of the word lethargic or whatever word is being used. For example, as we look at this question, we see lethargic. Most of us normally would think of the word maybe lazy. I'm feeling lethargic, sluggish, don't have a lot of energy. And of course, that's in the answer choices there because that's the easy answer. However, we need to look at the context. So I'm going to scroll down to that part of the passage. What we want to do, our best strategy for questions like this, is ignore the word lethargic altogether. In fact, to help us do it right now, I'm just going to cross out that word altogether in line 84. We're going to think of that as a blank. What we're going to do is we're going to try to fill in the blank with our own word based on the context that we read. So let's take a look. I'm going to read, let's see, at least the sentence before. So I'm starting here at he thought. He thought he was prepared, but the fatigue left him so dry and frail. His purpose leaked away and his thinking grew blank. So here we have some evidence that our character was fatigued, tired. So we can think of that word regarding lethargic, tired, and that tiredness made his purpose leak away. So he's run out of sort of that focus, that goal, that purpose. And therefore, what would happen to his thinking? You can put yourself in that situation too. You get really tired. You're feeling all run down. Fatigue leaves your brain feeling what? Does it leave your brain feeling lazy, as we might have thought lethargic meant? Not necessarily. It's not that your brain doesn't feel like thinking. It's that your brain isn't necessarily working so great, right? And perhaps we would even say that at times like that, we feel drained. And as we look at our answer choices, we don't have any direct evidence to support that the person was feeling confused. Sometimes that can be a part of it, but that's a little bit step further from what we've got here. We know that the key word here is fatigue. So when you're tired, your brain feels drained. Understated is just not related to the evidence that's put in the passage here. So our goal on vocab and context questions like this, use the passage itself to tell us what sort of word would fit in that blank. We want to try, if we can, to predict what word or phrase is capturing the meaning there, and then look at the answer choices. So I hope that helps with that question. Let me clear this off the screen for us. And we have another question. It says, how can I make sure I get a 30 on the math section if I'm scoring a 26 to 28 right now? It's mainly the questions after 35 that I get all of my mistakes. Okay, so really solid question here. How can I improve several points? And several points is a decent amount of improvement. Some questions that I don't know about you that would definitely play into this are, how much time do you have before your exam? How much prep have you done up to this point? But let's talk in general terms. So to increase your score in the math section, obviously the most basic way is to get more points. It sounds like you're doing pretty well in the first half. So as a reminder, the math section is 60 questions long, and they go approximately roughly in order from the easier questions at the beginning to the hardest questions at the end, though what you find difficult might vary. So the first half is doing fine. It's really the second half of the section that you're struggling on with your mistakes. The way the ACT often increases difficulty level is by adding layers of complexity to the question. So sometimes the same question can be tested in a very simple, straightforward way, and maybe a problem 1 through 15 question. But then in, say, problem 25 through 40, that question might still use the same information, the same mathematical concept, but that information could be buried inside a word problem or inside an extra step that you might have to take to solve for that number. So when we look at the later part of the math section, a lot of times it's the additional steps that keep us from getting to the right answer. To help you focus on the right answer, always make sure you're paying careful attention to what the question is specifically asking you to find. For example, the question might be asking you to find the value of x squared, but you have solved for x. And not reading those details carefully about what the question is looking for can make us choose the wrong answer. We also want to be careful that we're not making quick, what we call simple mistakes, things like calculation errors or writing down the wrong numbers on our answer choices. Beyond that, we definitely want to look at some of the more advanced concepts that you're going to see in the later part of the sections. So my advice to you would be to look over the practice that you've done so far, especially if you've taken any practice tests. It sounds like you've been practicing because you know that the late part of the math section is where you're struggling. Look for patterns in the types of questions that you're missing and the types of mistakes that you're making. A good way to do that can be to make some sort of list or log or summary of your mistakes. That way it'll tell you which concepts and which strategies you need to focus on the most to start picking up more points in that later part of the section. All right, we have another good question. Where is a good place to start studying for the ACT? Well, of course, we're going to recommend Magoosh is a good place to start studying, but let's talk about more conceptually. The first thing I recommend a student study is the format of the test itself. Become familiar with what the sections are, what number and what type of questions there are, because you might be familiar with the concepts, the English words, the reading, the math, but the way that they're tested on the ACT is a specific skill that you want to test for. After that, a really good place to start is by taking a full-length practice test. If you haven't taken one recently or if you haven't taken the ACT before, that'll give you an idea of what your current score level would be based on your knowledge of how to take the ACT. When you compare that score with your goal score, then you'll get a really good idea of whether you need to focus on studying for all different sections of the test, or if you need to put more of your emphasis on only some of the sections. That first score can give you a really good insight. From there, then you can start looking at resources and pulling together some materials that'll help you to study those concepts after you've identified what your personal needs are. Another question, how can I improve my pacing for the math section? That's a great one. So pacing is definitely a challenge on the ACT. In the math section, we have 60 questions and we have 60 minutes. So if you get stuck in one question for several minutes, time is ticking by, and you might not notice how much time has passed in that big block of time. So what you want to shoot for is an average of about 1 minute per question, 60 questions, 60 minutes. However, the questions that are simpler and easier for you, should take a lot less than 60 seconds a piece or 1 minute a piece. That way you can budget some of that leftover time for the harder, more complicated questions later in the section. A great way to work on pacing is to practice the strategy of learning which questions to skip and come back to. You want to look for questions that either you have no idea how to start, or you can tell they're going to take you a long time and a lot of steps to work on. Those questions, it's good to circle them, or if you're taking the online test, write down those question numbers on your whiteboard. That's your list of what to come back to at the end. Work through all the questions that you feel won't take you quite as much time. And then whatever time is left in the section, then you can come back and work on those questions that you circled and marked to come back to. Because remember, every question is worth the exact same amount of points. The harder questions aren't worth more than the easier questions. So you want to get all the points that you can on your first pass, then you can come back. When you do come back at the end of the section, make sure you leave yourself a couple of minutes at least to do that. And you want to make sure that you've left no blanks. You've submitted an answer for every question because there is no penalty for wrong answers. So you want to think in terms of maybe every 10 minutes or so, see if you've gotten at least through another 10 questions. Hopefully even a little bit more, because your goal will be to leave a few minutes left at the end to come back and go through the questions that you can work on again. And that takes practice. Pacing definitely takes practice. Hello, Tenku. Which topic is most frequently asked in the math section? Oh, there are so many topics that could be asked. So we talked a little bit about complexity. So the basic sort of layer of mathematics might be the arithmetic that we first learned right before there came to be letters in our math, when everything was just numbers. Those foundation arithmetic skills are then built on when we add in algebra. From that point, there are some algebra 2 questions built into the ACT, as well as some geometry and some trigonometry. For the most part, arithmetic, algebra 1 and 2, and geometry are the main topics that are tested on the ACT. If you have the opportunity to pull up a full-length practice test, an official test from act.org, then reviewing that after you've worked through that test will give you a great idea of which concepts keep coming up over and over and over again. Definitely you'll see a lot of algebra, arithmetic, and geometry. Can you explain the fundamental counting principle? I can briefly explain the fundamental counting principle. It says that if we have a number of different decisions to be made, then each decision can be made a certain number of ways. We can count the number of ways each decision can be made, and then we can multiply them together to get the total. For example, let's say we were making dinner. Let me pull up a quick little screen here just to make it a little bit easier for us to follow along together. Let's say that we were making dinner together. And first we were going to choose an entree, the main course, and maybe we could pick from chicken, pork, or vegetarian, 3 options. Then we're going to pick a dessert. And for dessert, you can have either cake or ice cream, 2 options. And with your dinner, you can have a beverage. You can have water or Coca-Cola or iced tea or lemonade, 4 options. So the question might ask, how many different combinations of entree, dessert, and beverage can you get? If we choose from one from each category, then the FCP, the fundamental counting principle, means we're going to multiply the number of possible entrees by the number of possible desserts, by the number of possible beverages, and we find that there are a total of 3 times 2 is 6 times 4, 24 different dinners. So that's a basic quick overview of the fundamental counting principle. Thanks for asking about that. That's a good question. And let me get back over here for you. All right, let's see. I keep taking the ACT and I'm not seeing much improvement in my score. Would you recommend taking the test and focusing on one section each time I take it, or studying more and doing all subjects? That's a hard one to give you the definite right answer, because it can depend on several factors for you. One thing that I would ask you to look into is whether the colleges and the scholarships that you are looking to apply to with that ACT score are willing to do something that's called super scoring. If you're not familiar with super scoring, basically it means that if you've taken the ACT on multiple times, and on one day you had a higher reading score and a lower math score, on a different day you had a higher math score and a lower reading score, they'll take that highest math score, that highest reading score, the highest score also from science and English, all 4 sections, and average them together to make a super score or a best score, even though you never actually scored that on the same day. If the programs that you're looking into allow that, then what I would recommend is from the ACTs you've taken so far, because you said you keep taking it, pull your highest score from each category, average those 4 together. So again, the 4 main categories, not counting the essay, that's your ACT score: English, math, reading, and science. Pull your highest of each of those 4 categories, add them together, divide by 4, and that'll give you your super score, ACT score. That'll give you an idea of how much you might need to increase that score by if you want to get to a certain goal. If the programs allow for super scoring, you might see that there's one category, one subject area that you particularly haven't been doing well in. And it might be that you can get the biggest score improvement overall by focusing on that one category specifically. If your scores are pretty consistent across all the sections, then I would step back and I would spend some study time looking at what types of mistakes, what types of errors am I making? Is it because I'm missing out on actually understanding what I'm reading? Is it because I have a lack of knowledge of math concepts? Or is it because I'm falling for answers that sound right, but are actually not correct according to what's written in the exam? Do I need to study grammar? Do I need to practice timing, pacing? A lot of times we might be familiar with the questions and confident on how to answer them, but we're running out of time. You can identify what specific weaknesses are causing you not to improve. That can give you a good idea of what to focus on the most. Generally, whatever your weakest area is, if it's far below the others, pulling that one up will have the biggest effect on pulling up your overall average score. I hope that makes sense and helps. Can I explain exponential equations? Well, that's a really big question in a wide category. There are some types of exponents that are tested on the exam, and there are some that are not. So generally when we say exponential, we actually mean when there's a variable in the exponent of a question. Questions like that are not major topics that we want to use for the ACT, but there are some properties of exponents that can definitely be tested on the exam. So the properties of exponents that we want to know the most are the ones that we might see at about an Algebra 1, Algebra 2 level. For example, most of the questions about how to work with multiple exponents have to do with combining different terms that might have the same base in different exponents. For example, let's say you have something like a to the x and a to the y. So here we have the same base, we have different exponents. What are different ways that we can combine those, and what would we get? One thing that we can do is we can multiply these two together. And the rule, if we're multiplying a to the x times a to the y, is that we add the exponents. That would be now a to the x plus y power. The opposite of that, the opposite of multiply, is divide. So if we divide a to the x by a to the y, now instead of adding the exponents, we will subtract. We would have a to the x minus y. Another common situation that's very basic and very general, and we see it a lot because the test likes to test this one. This is one that's commonly misunderstood. If I have something to a power, a to the x, and I'm raising that all to another power, so we have a power to a power or an exponent to an exponent, then we would multiply those two powers. It would become a to the x times y. Some really good general exponent properties include anything to the 0 power equals 1. 1 to any power also equals 1. And if we have different terms that we're adding together, a common mistake people make is thinking that if we are adding, that we can also add the exponents and get x plus y. This is mistaken. That is not correct. You will commonly see questions that include that mistaken thought on the exam also. We also see exponents come up in exponents of 2 specifically with anything quadratic. So a quadratic means anything where the variable has a power of 2. So you can have something very simple like x squared equals 4. That means what number times itself equals 4? And the answer could be 2 or -2. Those are some of the most common ways exponents can be tested on the exam. Hope that gives us a good foundational idea there. We have another question coming in, and this one is a Magoosh math question. So let me pull it up so that we can all look at it together, and let's see what we have. In a development with 100 houses, 75% of the houses with aluminum siding have 3 or more bathrooms. If there are 12 houses with aluminum siding that have 2 or fewer bathrooms, how many houses in the development do not have aluminum siding? This one is marked difficulty hard. And the thing that makes questions like this hardest is that there are so many little details in this word problem. It's easy to get lost and sort of overwhelmed, and it can be hard to sort out all of those details. So what I can recommend in a situation like that is that we just take one part of the sentence at a time and try to understand the details. A good way to break the sentence into pieces is if we have punctuation. So first we have in a development with 100 houses. That tells us the total number of houses altogether. 75% of the houses, now be careful, it could be really easy to think, well, that's 75. But it's not 75% of the total houses. 75% of the houses with aluminum siding have 3 or more bathrooms. So this tells me that I have some houses that have aluminum siding. I'm going to put AL for aluminum, and within that, there could be 3 or more or some other number of bathrooms. Next, if there are 12 houses with aluminum siding, so we're in this category, that have 2 or fewer bathrooms. Now we know what that other number of bathrooms is going to be. And we could have guessed, but now we know for sure. Could have 3 or more or 2 or fewer. Then how many houses in development do not have aluminum siding? That's what we want to solve for at the very end. So before we answer the question, we're going to go back and check for what we needed to solve for. So what do we have? 75% of the houses with aluminum siding have 3 or more bathrooms. So out of all of the houses with aluminum siding, 75% have 3 or more bathrooms. The only other option is 2 or fewer. So if 75% are already accounted for, then what percent remains? Well, the total of anything is always 100%. So if we already used 75% with 3 or more bathrooms, that means the remaining for 2 or fewer would be 25% of the houses with aluminum siding. Does that make sense? Then we have, if there are 12 houses with aluminum siding that have 2 or fewer bathrooms. So that's this category here. Aluminum siding, 2 or fewer bathrooms. We found out that's 25% of the group with aluminum siding. And that equals exactly 12 houses. See how we've now taken all of these words that were very complicated, confusing, and now we've put them down into our own personal notes. So when you're taking the test, if you're taking the paper test, you will have your test booklet. I encourage you to write all over it, take notes, mark up the questions. If you're taking the online computer-based test, you have a whiteboard. Use that whiteboard, again, to write down notes, write down details. It's very helpful on the test to do a lot of writing while we go. So our question is, how many houses in this development do not have aluminum siding? Well, we don't have any information yet about houses that do not have aluminum siding, but we do have plenty of information about the houses that do. So our plan here is that the total number of houses, T for total, is going to equal the number of houses that have aluminum plus the number of houses that have no aluminum. We have enough information given to us to figure out how many houses have aluminum siding, and then we'll figure out the final answer. So we can say that 25 or 1/4, 25%, or 1/4 of the number of houses with aluminum siding equals exactly 12 houses. Does that make sense so far? So if I want to find the total number of houses with aluminum siding, I can multiply both sides by 4. That's one way we can solve this. And then we find the total number of houses with aluminum siding equals 48. Notice 48 is in our answer choices. It's there for us to choose if we haven't read all the way to what the question is really asking. And finally, we know that the total number of houses is 100. So that must equal the number with aluminum siding, 48, plus the number that do not have aluminum siding. So 100 minus 48 gives us our final answer. There are 52 houses that have no aluminum siding. This one is difficult, not because of the calculations themselves. It's not hard to multiply 12 by 4, especially with a calculator. What makes this different is that we have to sort and organize all of the information. So once we've done that in little pieces, then we can piece them all together, make sure we're answering the correct question, and find the total. If there was a specific detail of that that's still unclear, you can throw it in the chat and I can try to clarify. I hope that explanation helps. What else can I help with? In the meantime, let me get cleared up from this practice question. Actually have no questions that are live for me right this second. So if you've been waiting, this is a good moment to get your questions into me and I will be happy to help. Remember, if you're a Magoosh student and you joined the Zoom meeting directly, go ahead and use the Q&A function to submit your question. You can choose whether you want to put your name on it or submit anonymously. If you're viewing from YouTube, go ahead and use the live chat and Hian will help us make sure your questions can get to me so that we can discuss them together. In the meantime, if you're watching on YouTube, I'll take this moment to mention that we do have a special sale running right now, 20% off any ACT or SAT plan. So you see at the bottom of your screen, we have the coupon code listed there, office hours 20. Because you attended today, we want to offer you, if you'd like to join us at Magoosh and see what we can do to help you with your SAT or ACT score, or both, go ahead and use that coupon code for 20% off your subscription. And that way we'll be able to give you all of the best, clearest premium help. And you can attend these office hours every week. We'll be having them 3 times a week, every week, but only this week are they going to be broadcast on YouTube. After that, Magoosh Premium students can continue to enjoy office hours, ask their questions, and get answers 3 times a week live. We also have an option for you to submit a question about study help, about your ACT score, about how to study, and about specific questions from any of our lessons or practice problems through email 24 hours a day. And we have an entire team of test prep experts who are standing by ready to help with those emails 7 days a week. Again, are there any questions coming in on the YouTube chat? Ooh, kind of a big general question. We've got two questions that came in just at the same time. One is sort of a general concept question, and one is a specific practice question. So, sorry, I get a tickle in my throat when I'm talking. Let's start with our general concept question. The question from Sean says, can you please summarize circles, arcs, and sectors? Yes, I can. To help me do that in the clearest, easiest way possible, I'm going to draw a circle for us. Basic principles that we need to know about a circle. There's a point in the middle, and that is the center of the circle, and every single point on the edge of that circle, no matter where, is the same distance from that center point. That distance is called the radius. If we have two radii attached end to end, going straight through the middle of the circle from opposite ends, then that's called a diameter. It is always the case that the length of the diameter equals 2 times the length of the radius. Basic formulas for a circle we need are that the area equals pi times the radius squared. Remember, pi is that special number that goes on forever and ever, but the first few digits are 3.14. Most of our circle questions on the ACT, we can get a good close answer by using the approximation 3.14. We also need to know that the circumference, or the area, the distance around the whole outside of the circle, if we drew a straight line all the way around it, that equals 2 times pi times the radius, or pi times the diameter. We come in a different color now. Sorry if that was loud near the microphone. Circles can be broken into different pieces, and a good way to illustrate those pieces is to draw 2 radii that slice the circle into this wedge shape. You can think of it very much as if we were slicing a pizza into slices to eat. We would start from the middle and we would draw 2 lines out to the edge and we would make a slice of pizza. So there are 3 important parts to the slice of pizza. There's an interior angle that can be measured in degrees or radians. There is the space inside the slice of pizza. If we filled this all up and colored it in, the actual surface of the pizza, that is called a sector of the circle. And then the distance along the edge around the circumference, if we, instead of going all the way around the circle, we just traveled from one edge to the other, that's called an arc of the circle. The important properties for arcs and sectors will be tested on the exam is that these are all in ratio to the total size of the circle. And that ratio we can usually identify based on the angle. So here's the facts we need. We need the total number of degrees or radians, the total angle measures of a circle is 360 degrees or 2 pi radians. The angle inside of that arc divided by either 360 or 2 pi, depending on whether we're measured in degrees or radians, is the exact same ratio as the area of that sector divided by, this one a second line to make it easier to read, divided by the total area of the circle. And that's also the same ratio as the length of the arc along the outside edge divided by the total circumference of the circle. So if we know part of those relationships, we can calculate the others based on the fact that that slice represents a portion. For example, let's say that our angle measure in this sector is 60 degrees, and the circle altogether is 360 degrees. That means that this slice would equal exactly 1/6 of the circle. If we cut the pizza into 6 slices, this is 1 full slice. That would mean that the area of the sector equals 1/6 of the total area of the circle, and that the length of the arc equals 1/6 of the circumference of the circle. So there's a good quick little summary about circles, arcs, and sectors. Hope that's helpful. To clear the screen now, we're going to look at another practice problem. Okay, let's see what we have here. This is a science problem. So I'm gonna make the screen a little bit bigger. We can see what's going on here. Science problems can seem really intimidating. I encourage you to think of them as reading comprehension questions because the answers are based on reading in the passage, just like on the reading section. The difference is that there can be information presented not just in words, but also in graphs, in charts, in different sorts of information. For example, on the passage that we see here, first we have a brief write-up of the topic. That's very common. Then we have one experiment described to us. We are told that the results of the experiment are presented in figure 1. And here's figure 1. This is meant to look intimidating because we're not used to reading charts or graphs of this type, but we don't stress out too much because all of the information we need is presented there. Then we also have some more information being presented in figure 2. And as we scroll down, we see that figure 2 is another sort of similarly laid out charts. What's different in all of these graphs, we want to look at what the axes represent, and we can look for patterns for which charts are increasing, decreasing, fluctuating, what they're doing in different time periods. And then in experiment 2, we are repeating the procedures. We're doing the same thing, and we're measuring something different that's presented in table 1. Table 1 gives us information organized into a table rather than charts. There are big words here. Again, we're not going to stress out. We use the information that we need, but we don't need to become an expert on what these experiments were or what they mean. And then experiment 3, we have another table, table 2, presenting similar information. They would have made some sort of changes for this. So that's a very big picture overview of what we have going on. We have an experiment that took place. Different things were measured and presented in graphs. Then the same procedure was repeated. Something else was measured. We have that in a table. And then it looks like something else from a similar experiment was measured in a third table. Okay, now let's look at our question. And this one is marked hard. So it's fine if this one seems a little bit like something to get bogged down in. A lot of times there are specific detail questions in these science passages, and by working through those first, we can have a little bit better context for what's going on overall in the passage before we get to the more detailed ones. So we have, prior to the experiment, the researchers hypothesized or guessed, their theory was that the subject's heart rates would be more constant during meditation periods than during the control periods. I'm going to mark that, highlight that, because that's what I would do on the exam. So heart rates more constant during meditation than during control. Do the results of experiment 1 support this hypothesis? So we need experiment 1. We've scrolled through, we're back to the top, and we need to look at heart rate specifically. Here's where we can scan just a little bit to figure out what's going on in this, and more specifically, which figures we're going to need. Now, I see that the first chart under figure 2 specifically is marked heart rate. So I'm going to focus on this graph or chart. And the question is whether heart rates would be more constant during meditation periods and control periods. So as I look at my x-axis in time, I've got a period of control, a period of meditation, a period of control, a period of meditation. What kind of trends do we notice? Well, as I look at the first period of control, that's sort of the initial information we're looking at. I see lines moving up and down. It might remind me of what you see on a monitor, a heart monitor in a hospital, right? And I don't know, the line in that section looks kind of thin, maybe. Then as I look at the next section, meditation, I see that the line looks thicker. Why does it look thicker? Well, because there are more peaks and valleys that I'm seeing. I can also compare the highest and lowest values. So within section 1, we're kind of right at the middle of the number 2. And then a little bit below the 62, maybe I could estimate between the bottom and the top, about 8 maybe. And then during the period of meditation, we're starting out down here, but our highest points are up here. So maybe 54 to 64, a little bit higher range, right? And we see that the distances between peaks and valleys is a little bit wider. Overall, we can see that the control section looks a little bit calmer. Even if we're not expert at reading graphs like this, that's fine. So the question was, is the research showing us that heart rate is more constant during meditation? No, in fact, we see that the heart rate is a lot more smooth and calm during the control period, more varied, more wide during the meditation. Now we look at our answer choices. First, on questions like this, we'll always have yeses or nos, 2 yeses, 2 nos, and then we're going to have a reason. We've decided the answer was no, so we're going to eliminate our 2 yeses. Then we're going to look at the reasons. Answer choice C says no, because average heart rate increases during meditation periods, but remains nearly constant during control periods. Answer choice D says the opposite. Average heart rate decreases during meditation and remains nearly constant during control. So what did we see during that meditation phase? Do we see the heart rate increasing or decreasing? Well, in our meditation phase, the heart rate was higher overall than what we saw in the control phase. And the control phase was kind of more level. That's exactly consistent with answer choice C. The average heart rate was increasing during meditation, this part here, and was more constant during control. So we sorted through all the details. We took just the information we needed from one chart instead of getting lost in all the information in the science question, and we arrived at the correct answer. If you have any clarifying questions that you'd like to ask about that question, I'll be happy to help. Some really good questions coming in, some concept questions, some specific problem questions, some how do I study questions, really good questions. So keep them coming. I don't know if my microphone is picking it up, but if you hear the sound of children playing, that's exactly what you're hearing. Children playing downstairs from my apartment. And remember, if office hours has ended today and afterwards you thought of a question you want to ask, If you're a Magoosh Premium student, you can email help@magoosh.com. I'll be happy to help. If you are not currently a Magoosh subscriber, you're welcome to come back on Friday for our other office hours live on YouTube. This week, Friday, it's going to be at 10:30 Pacific in the morning, 1:30 in the afternoon Eastern time. All right, we've got another question that's come in. Let's take a look at it together. All right, we've got a geometry question here, and more specifically, we've got a trigonometry question here. This is the sort of question that we're going to be able to answer if we know our basic trig properties, and if not, then there's really nothing we can do. So let's see, what do we have here? First thing I always recommend on a geometry question is to draw a diagram. In this case, this one's already given to us, so that's great. We have a figure. If you have a question about a triangle presented and it doesn't have a picture, then either on your test booklet or on your whiteboard, go ahead and draw that picture, mark it up, write all over it. It's going to be super, super helpful for you. This one, as I examine it, I see that we're working with sine and cosine. So again, if you're unfamiliar with those, never heard of it, then that's trig knowledge that you just need to answer a question like this. So if that's something that you just don't have, probably your best bet is going to be to skip this question and move on, pick an answer, guess. But if we have a little bit of trig knowledge, when we think of sine and cosine, then hopefully we will remember the memory aid called SOHCAHTOA or SOHCAHTOA. It tells us that for any of the smaller angles in a right triangle, we can take the sine of that angle, and that equals the opposite leg over the hypotenuse. The cosine equals the adjacent leg over the hypotenuse, or the tangent equals the opposite leg over the adjacent leg. In this case, I'm asked to find sine of 30 degrees and cosine of 30. And then we're going to subtract them, and then we're going to square that difference. If you happen to have some trig properties in your head that are familiar, that would help. We're just going to stick with sine and cosine as they're given to us here. Okay, so sine of 30 degrees equals the side opposite over the hypotenuse. So let me grab my pen here. My 30-degree angle in the triangle is right here. All of the side lengths are marked for me. So let's identify the longest side across from the right angle is the hypotenuse. The side completely on the opposite side of the triangle is our opposite. And the side that touches our angle and is not the hypotenuse, that one is the adjacent. Great. So we need to plug in our values. The sine of 30 equals the opposite. Well, let's see, the side opposite all the way across is 1 divided by the hypotenuse, 2. So the sine of 30 degrees equals 1/2. Great. Cosine equals the adjacent. So my adjacent equals the square root of 3. So there's not an easy way to type that on my keyboard real quick. Divided by the hypotenuse, 2. From here, I'm going to switch back over the pen. So we have sine equals 1/2. Cosine equals square root of 3 over 2. Now we need to take those numbers and plug them into our little formula. So we're going to have parentheses, sine of 30, 1/2, minus cosine of 30, root 3 over 2. And we want to find all of that squared. Let's take a quick side detour. On the ACT, there is a factoring formula for binomials or items of two terms that the test just loves, adores, wants to use all the time, thinks it is the greatest thing in the world. And that formula is called the difference of squares. Anytime we have certain factoring formulas, we want to use them on the exam. So we have the difference of squares, and we have that. We also have a square of a sum and square of a difference. Those are less common for us to study, perhaps. This one is definitely a square of a difference. What that means is that we're going to have a special formula if you remember it, if you know how to use it. Whether you do or not, we're going to expand this out, and it might seem very familiar to use something called FOIL. So we have 1/2 minus square root of 3 over 2 square root of 3. Since that's being squared, I'm going to multiply it by yet another 1/2 minus square root of 3 over 2. FOIL tells us that I'm going to organize my multiplication this way. I'm going to do first term times first term. 1/2 times 1/2 is 1/4. Then we're going to do outside times outside. So 1/2 times negative square root of 3 over 2. It's going to give me minus square root of 3 over 4. Remember, when we're multiplying fractions, we go straight across the top and straight across the bottom. Then we're going to do inside, negative square root of 3 over 2 times 1/2. So again, minus square root of 3 over 4. And then finally, I'm going to take last times last. I have negative square root of 3 over 2 times negative square root of 3 over 2. So let's take one piece at a time. A negative times a negative is a positive. Square root of 3 times the square root of 3. Anything that is a square root multiplied by itself makes the square root cancel out. That leaves us with 3. And then my denominator, 2 times 2 is 4. We're almost there. Now let's clean this up. We're going to see that we've got two fractions that don't have a square root in them. Let's combine those. 1/4 plus 3/4 equals 1. And then we have two that do have a square root in them. We have the square root of 3 over 4 being subtracted 2 times. So we can say that we have 2 times the square root of 3 over 4. And a little quick simplifying fractions means we can get rid of that 2, factor out a 2 from the top and the bottom. That gives us 2 in the denominator. And that's how we can find the correct answer, E. Again, this is a question that if you don't know your basic trig identities, just like we had here, our SOHCAHTOA, sine, cosine, and tangent, then there's nothing you can do to fake your way through this problem. You either know what it means or it doesn't. So if you find yourself on a problem like this on the test and you don't know what sine or cosine even means or what to do with it, it's not worth spending time trying to figure it out. That's a question that would be best for you to guess and move on. If you do, then this basic rule, SOHCAHTOA, will help you with a great deal of the trig questions that we see. In fact, there's a question in the chat about fundamental trig identities, and the most fundamental ones that we're going to use in all of trig, and especially on the ACT, are the ones we've summarized here. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. I'm going to, sorry, I got a tickle in my throat. Get rid of some of this extra. And we can add to that a little bit. There are also 3 corresponding opposite identities to sine, cosine, and tangent. The one that is the opposite of sine is called cosecant. And that's just sine upside down. So it's going to be hypotenuse over opposite. The opposite of cosine is called secant. And that's cosine upside down, hypotenuse over adjacent. And then the opposite of tangent is called cotangent. With that one, we get adjacent over opposite. These can be a little harder for some students to recognize, or to memorize rather. My suggestion is, we know tangent and cotangent go together. They contain the same word. After that, we have sine and cosine, cosecant and secant. There are 2 that start with the letter C, 2 and start with the letter S. I memorized years ago that they just pair up in opposites. Sine goes with cosecant, cosine goes with secant. So they pair up in opposites, C with S, S with C, and that helps me remember cosecant, secant, and cotangent. Hope that's a helpful review of the trig identities. We can also perform operations called the inverse trig functions. So in that case, we would put in the sine, the cosine, the tangent, and then the output would give us the ratio between the opposite and the hypotenuse. If you've learned those in trig class, a good reminder for you that those are the inverse operations that go with these. Great, that was a good opportunity for us to discuss a practice problem and a concept problem together in one. Very nice. We have about 5 more minutes. So if you have a question that you haven't gotten answered yet and you want to send it over to Hien in the chat on YouTube or to me in the Q&A portion of our Zoom meeting, go ahead and do that. Try to answer what we can with the time remaining. While you're thinking of one last question you'd like answered, I want to remind you, if you're a Magoosh Premium student, you can always check the calendar to find future office hours. When you log into your account, there should be a banner at the bottom of your homepage that directs you to that. And there's also a page that you can bookmark. Once you get to that page, it's act.magoosh.com/office-hours, I think. Once you get to that page, if you bookmark it and you come back to it later, that page will continue to be updated with the office hour schedules for future weeks. We will be having 3 sessions a week in the coming weeks, but the hours might be a little bit different from one week to the next, depending on what we can offer. After this week, we're hoping that they'll be pretty consistent, pretty predictable most of the time, but please always do check the calendar and make sure, rather than just assuming that we're going to have office hours always at the same time. For this week, YouTube students, we're happy to welcome you back on Friday. Like I said, 10:30 in the morning Pacific time, 1:30 in the afternoon Eastern time. Be back up on YouTube. You'll find the link for that meeting or that YouTube video live stream just the same way that you did for this one. And you can bring some questions that day as well. If you'd like to sign up for Magoosh, join us and get access to these office hours 3 times a week, every week for the foreseeable future, go ahead and use that coupon code. We want you to save 20% with the coupon code OFFICEHOURS20 that you see right now at the bottom of your screen. We can also help not just with general concept questions or study help questions, but we're happy to support any Magoosh practice problem that you found or any free official problem. So the ACT test makers, they release a document that's called Preparing for the ACT. And that document is a PDF. It contains a full-length ACT practice test. It's a great resource for you that you can practice the ACT for free. And those are official, authentic questions. And it just so happens that there have been different versions of that document released over the years. So there are a few different free ACT practice tests that come straight from the official test makers that are out there. If you have questions on any of those at Magoosh, we're very happy to help with those as well. Looks like we just have a couple minutes left and no more questions have come in yet. So if you're headed out, I want to thank you so much for coming and joining us today. Had a really nice discussion. I enjoyed working on some of the different concepts with you, some of the questions. Let's see, we had math, reading comprehension, and science, I believe. So 3 out of 4 sections that we touched on today. That was good, a nice review. We had some math concepts that we had a little quick crash course on. That was really nice opportunity to remind ourselves of related concepts that we can see tested on the exam in different ways. Focused a little bit on geometry more than on other things with our trig problem, with the circles and arcs and sectors. We talked about a lot of good things today. So thank you so much for coming. Look forward to seeing you in future office hours. Again, there'll be one more this week on Friday. And then next week we'll have a different schedule. So make sure you check the page that you used to get to us here today for upcoming schedules for all Magoosh Premium students. All right, I show that we're about out of time, and since there were no lingering questions at this time, I'm going to go ahead and wrap us for us. Thank you so much, and we hope to see you again, Magoosh Premium students, and those who are thinking of studying with us. Come on over, we'll be happy to help you to be prepared, confident, and ready to get the ACT score that you need to reach your goals. Bye-bye, Sean. Thank you for coming. Look forward to working with you again. Bye, everybody.